So now there is a very interesting technique which can help us to keep our model simple. In fact, it do help us in creating some sort of balance between the things, which is a regularization technique. In fact, this regularization technique I'm gonna teach in much more depth later. This is gonna come in further module where you will notice with respect to your regressions, we will discuss something like what is a lasso regression, what is a ridge regression, and we will perform various things on top of it. We will even do some Python code on using this and see that how it can improvise things for us and how we can perform all this. But for now, we will understand that what is regularization. So what regularization basically do, just to give you an example, remember the loss function in regression, which was y minus y hat whole square, right? We were doing the sum of for all the points here. Now, so basically, I can put it from I going 1 to n, and this can be represented as yi minus what? So this is basically your coefficient values, right? So w naught plus w1 x, right? So this is going to be the part and whole square. Now, during the optimization phase, when we tries to optimize this function, what you try to do, you would like this value to be near to 0, right? That's the best value you can get. Now, in order to reach to this value 0, what you will be trying to do is basically you would like to, if assuming that let's say yi hat is lesser value, in that case, you would be trying to increase the coefficient value of w naught and w1 in such a way that your basically it should come close to yi and it should become almost near to 0, right? That's what you will try to do. Now this, due to this, what will happen, my coefficient value w1 w naught is going to increase a lot, because during this fight it will try to increase this values of coefficient in order to make the or this loss value equivalent to almost 0. Now, in order to handle this situation, because now you can easily see that we are going towards a complex model here, and we would like to avoid that. So what we do in this case, we say that, okay, y minus w naught plus w1 x. So this is going to be the part, but what we going to do is I'm gonna include another term which is going to be w square. Okay, so wi square. What basically this means is, so basically this means is that let's say if in order to try to minimize this loss value, you try to increase the value of w naught w1 so that you can bring this error term to 0, but during this process this value will keep on increasing, so you are putting a penalty for it here, which is going to increase the value of my w, right? So so if you try to increase here to make it 0, then you are getting a penalty here, right? So that's the part. Now there is one more thing which we do in this, and definitely I have not put with all the eyes and all that here because this is just to give you intuition. As I said, this is going to come later in detail when we're gonna learn about regression concepts later. Means we have already talked about regression, but we will learn even more advanced regression concepts later, and that's where I will be introducing you with this term in detail. Now, we do also one more thing here. We add a lambda parameter to it. What is this lambda parameter going to do for me? So if I want to make sure that the penalty is going to be huge in case I try to make my model complex, so in that case I would keep the value of lambda to be high. But in case if I want to basically put less penalty for this, then I would keep the lambda as low. And if we keep the value of lambda as 0, it means that there is no regularization happening in this case. So basically here what is happening is there's a tug of war happening, right? If you look at this, if you increase this to make it 0, then this will increase. So there's a tug of war. So that's what you have to balance. Now this lambda value, I don't know what is the best value for my data. So in this case, we consider this as hyperparameter. Okay. And we will learn now as a next portion that how to code all these hyperparameters, because we need to really understand that how we can code up these hyperparameters in the Python notebook, which is gonna come as a next step. If you remember in KNN topic also, I introduced you with a hyperparameter where k value was a hyperparameter. I don't know what is the best value of k. We tried multiple values and come to a point which we said that this looks like to be a best hyperparameter. So this is one way which we have to devise, and we will see in further lecture how to handle that. Now again, there is another point which we have already talked in Karen, but I want to make it generic again here because I'm going to use it further. So what we generally are doing till now, there is a data set which I'm dividing into train and test. And while doing this, what we are doing, we, let's say, created on the training data some model, and then we started testing it with a testing data set. Now there is a problem which happened due to this. The problem is that maybe this model do not comes out to be good. So what you did, you went back and you did some hyperparameter tuning again on the training data. You created another model M1, then again you tested it. Again it didn't come out well. Again you go back, did some hyperparameter tuning, maybe adjusting the value of lambda itself, and then again come to test. Now during this process you are kind of cheating, right? Because you are looking at a testing data set and then you are going back and doing hyperparameter tuning. So you are doing all the hyperparameter tuning based on the test data what you have. Now in order to handle this, what is the solution we have? We will take one portion of it as a train data. We will take another portion of it as a validation data, and we will take the last portion as test data. Now what we will do on that, we will not even touch the test data at all. All the hyperparameter tuning will happen between train and validation data. No hyperparameter tuning is going to happen for the test data. And when we will do this process, in the test data, once we get the final model which is properly hyper tuned, then we will test it with this unseen data, and then we will see if it is performing well or not. If it's not performing well, maybe you have gone for overfitting also. So these are the things we have already discussed, but again just repeated because we're gonna use this very sooner, all this concept.